All right, now I'm hoping that my hard drive has enough space on it. I haven't recorded this year. All right, so Sophia, hopefully you're having a wonderful birthday. We are doing 2, 3, 1. Happy birthday to Sophia. So when we're looking at 67, Erica thinks these triangles might be similar. She asks for our help, and we say they are drawn to scale. So if the two shapes are similar, what must be true about the sides, the angles? Let's just remind ourselves what similarity is.
The angles must be, they have to have the same ratio.
All right, one person at a time. So the angles have to be, what is math word better? Math word. Congruent. They must have, now what do you mean equal ratio? What sides? Just like any old two sides that I picked? What do we call it when like this side goes with that one, man? Yeah, corresponding sides must create equivalent ratios. So you're right, equal ratios, I'm trying to remind that, like, order matters, right? So we have to pick certain sides. So, again, I don't like printing things that I don't feel are necessary. So this would be the thing I waste a sheet of paper to print.
Okay.
I'm not going to. What would we do?
Just draw and do the congruence.
Yeah, we can draw, we can measure, right? We can take a protractor, we can measure the angles. We can use a ruler, and we can measure the sides, and we could determine, are those similarity ratios there? Are those angles congruent? That opened on that tab. All right, so moving on from that one because we're not wasting the resource page. So Ario thinks to himself, there must be an easier way, right? Because Ario's upset that we wasted paper, right? Just like me. So Ario's asking his teacher, like, well, instead of measuring all three sides, what if I only know that the angles are congruent? Would that mean that they have to be similar? So Ario builds this e-tool, and we can drag this around and do whatever we want. I hate that that resets back to there. All right, so if I open a new tab, I don't know. I mean, you have a good point. So here's our question. Can we make another triangle with the same angles that is not similar to our original triangle? So if we use the same angles, right? So 38, 80, 62. 38, 80, 62. For some reason, this will not let me zoom. So what happens when I move just one of the sides? The angles are changing, right? Because that point down at the bottom is staying fixed. So now, are we congruent? No, but if we reset, I did not mean to click on the box. I had to stop that to get that to go away. What? I know. I don't know why my mouse cursor does that. So when the angles are congruent, by the way, if you guys go in here, you can turn this on or off. Yeah. Yep. But again, we're trying to get through quickly. So we could drag this if the point was fixed. This e-tool is a little clunky, actually. But if things were fixed, we could drag on top, we could measure, we could find that similarity ratio, and we would say, yes, they are. So if we look at this e-tool, we now color code everything, right? But again, as I change things, ooh, wait, what is different about this e-tool? So what I do to one, yeah, it's like a reflection, right? Yes. Sorry, I'm trying to move quickly. All right, so let's help Scott now. Now, pay attention to the order. Now, you can use your graph paper day after day after. Like, you can use it for the next lesson. You don't need new graph paper for each lesson, just for each homework. So Scott has 87, 68, another 87, and a 25. Help Scott. Take a minute. What do you think? Are these triangles similar? And pay attention to his order. minutes to see what you think about this. How did you figure out the angles are the same?
You do the triangle thing.
Oh,
Triangle, angle, sum, theorem.
thank you. So then you found out that I is 25. So let's compare order. E, F, G. So what size is this angle?
That would be
68. So 68, 25, 87. H, I, J, 68, 25, 87. Right, same order. There we go. So how many pairs of angles need to be congruent to make sure that the triangles are similar? All of them, right? And that's for any shape. So for any polygon, if we're proving congruence, all angles have to be similar. But then why do we call it angle, angle? Why do we call that similarity theorem angle, angle? You just said we need all of them, right? Why do we just use angle, angle as the name?
Oh, yeah.
If we know 2, we really know 3. And here's the kicker, or like, here's what this really comes down to. Mathematicians are efficient. Okay, that's one of the things, like beautiful things about math. That's one of the reasons I like math. We don't waste time saying angle, angle, angle. We don't need to. Once we have 2, we have all 3. So if we know 2 angles are congruent, we know the third, we just call it angle, angle, triangle similarity. Now you could call it angle, 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 but people will kind of laugh at you and snicker and be like, well, that wasn't efficient. Why did they say that?
There's like parallel lines and all these things you only could
So what if we only have 1 angle?
Well, you can't prove it yet then.
Ooh, what about the sides, Liang?
If the sides are corresponding, then yeah. Because the sides have to be the same. They have to be proportional.
Is order, like, is there any specific order here that we've been told?
It's side, angle, side. Yeah.
Side, angle, side. But I mean, like, ABC versus CBA, like, have we been told any certain order?
Yeah.
No, and actually, these triangles don't even have 3-point names. We just have triangle with C and triangle with F, right? So if we compare triangle C to triangle F, what do we notice?
They're dilated.
What kind of dilation?
By 2.
Yeah, it's a scale factor of 2 or 1/2, right? We can go either way. And I think it was Liang already said it. We have 2 sides and an angle, and that angle is conveniently in the middle or between the 2 sides. So we have side, angle, side, right? The angle is congruent. The sides share that dilation, that scale factor. So we have side, angle, side, similarity here. So remember that, I know, you're going to keep saying congruence because your brain is stuck with it. So remember, we only use a squiggly. We don't use an equals. When we're showing similarity, we show a squiggly. Congruence has the equals with the squiggly. All right, so we know that, but then let's look at this question B. So, is it possible to make another triangle with sides that are proportional, right, like 8 and 6 or whatever, with the same included angle that is not a similar triangle?
No. It's not. Because we changed the angle on the side. Okay, so if the angle isn't changed, then the side can't.
Wait a minute. If the angle doesn't change, the sides can't. What? Who's gonna finish that? The sides can change without the angle changing, right? So that's why you stopped that sentence.
You can't only change one side without changing the angle.
Ooh, the sides have to change together. So if we make the 4 8, Liang is saying what else happens is the 3 has to become a 6. Or he's saying if I just make the 4 at 8 and leave the 3 at 3, the angle changes. It was a grant. I would like your folks to be here. So, side angle side, right? Side angle side similarity. Sorry, I'm trying to get through this quickly to give you plenty of time to work on practice because I know it's a big practice assignment, but they are important. All right, so side similarity. Right, side similarity. You already know that? What about it? But be careful. What we're looking at here is side similarity. So your brain is stuck on side congruence, right? Saying that they're equal. This is side similarity. The sides aren't equal, they are scaled, right? So with similarity, and you might want to jot this note like on your paper then, side, SSS squiggly, right? Similarity is indicating a scaled relationship. Well, if it's side similarity, yes. Yeah. Now, if side similarity has a scaled relationship of 1, then it's side congruence. Yep, so that scale factor is 2 or 1/2 depending on which way we're going. It would depend on which is the image and which is the pre-image.
If we just have 2 triangles, would we have to name both?
Both scale factors? They would tell you which way you're going. So they'd say triangle ABC was dilated to make triangle.
It always says that.
It should. Yeah. Or both answers would be correct. So if we look at B, analyze this for a second. Do we think it's similar? Yeah, because 3 goes to 6, 4 goes to 8, 5 goes to 10. They're trying to make it easy for you. Remember I said this is the regular lesson. So what about this? 3, 5, 7, or sorry, I think those are the same as what we just covered. Yep. Rovel's team. I think we can skip that. What about this?
If they have 2 sides and an angle, wouldn't it? No, that's side. That is side.
Here, I'll start this over. So these, as we see it, we have a 4, we have a 5, and we have a 50.
But it's similarity, not congruence.
I'm gonna be honest. If you would translate that on the back,
what was the angle? The top angle can be different.
I did not mean to grab that side.
You're gonna have like 50 tabs.
I know.
It's just part of being
Does this work or not?
I don't think
okay, so it's a potty word, so it can't work.
No, but that's only for congruence. I don't think it. I think it would be the same because it's similarity. I think it will.
Does side angle work for congruence?
No.
No. So do we think that it will work for similarity?
Maybe.
So Liang says yes. Why, Liang?
Because I don't see where you could change something without like messing with it.
But you said yes, it works.
I don't see where you could change the sides. So I'd make it that way.
So this model isn't really letting me do it, but I can swing this way, keep my 50, and especially with different, it may not work with these specific side lengths, but there are ways to recreate the triangle with the same angle and the same two side lengths, and it's not similar. Or, well, not same, but like in ratio side lengths, and it won't be similar. So, angle side still does not work, or side angle, as we want to say. But, angle side angle does. Right? Angle side angle does work. So, real quick, let's check these. We have a 32, a 52. Ooh, we got to do some math real quick. What's 32 plus 52? 32 plus 52. So then the complement, 96, right? So in A, are we similar?
Yeah.
Yeah. Ooh, we got to do some math here.
You got the calculator. You can do it. Okay.
I mean, it's times 3.2, but the 14 is what's going to be annoying. I think it's times 3.2.
I'll let one of them do it.
Yeah.
So that is.
There we go. As long as the 14 times 3.2 makes 44.8, we're good. What about part C?
Okay, so I thought that aside. Wait, are those lines
Because they both share close angle.
How do they both share? Oh, they do both share M.
They share.
They have two angles that are similar, so that means that the third angle has to be. Oh.
There you go. I didn't even have to use my pen. And what about D? What should I start checking? Like, if I'm going to do this division, how do I know what side goes with what side?
I know it's the similarity thing.
How do I know what to compare 18 to over here?
90.
Yeah. Smallest, biggest, right? So the smallest will go with the smallest, biggest with the biggest.
One guy has not drawn the scale.
Wait, it's not right. They're not.
Why, Leon?
Because the 211.
Oh yeah, the biggest is W.
And that's like about.
And I.
Ah, good work. Be careful. Check all three.
Let's do
Alright, I want to give you guys time to work on your practice work because it's a big practice assignment. So, definition, here if you want it, scale factor, ratio, similarity. Oh, by the way, if they say ratio of similarity, it's just a fancy way of asking for scale factor. It's 11 questions, but they should go quickly.
You know what?
You should work together.
You know what happened?
Alright, Sophia, homework, and that's it. So they're getting a bonus like 20 minutes.
Back then, this summer, I remember when I was doing homework and I finished a really long question, I thought I was done.